Oh, hey boys and girls. Glad to see you back. Welcome to your video on discrete and continuous data. I'm going to report to you from my submarine classroom. Yeah, something like that. Alright, so let's first talk about discrete data. Discrete data or discrete domains is the set of input values that consists of only certain numbers in an interval. So on a number line, I can count the numbers 1, 2, 3, 4, 5, so on and so forth. Those are what we call discrete domain values. For example, if you were to graph the clothing sizes for women or men, typically clothing sizes are in whole numbers. So for example, women's clothing sizes might be 2, 4, 6, 8, so on and so forth. Men's pant sizes can be 34, 32. Sometimes they have half sizes, but for the most part, typically men's clothing or women's clothing are in whole number sizes. The outcomes of a dice. If I were to roll a dice, I could only get the numbers 1, 2, 3, 4, 5, and 6. None of the other values are possible other than those, which are whole numbers, and they're numbers that can be counted. If we look at yesterday's Flyers game, or some sort of football game that might have been on TV, the number of hockey goals scored, or the number of touchdowns scored, we can't score half of a hockey goal, we can't score a half of a touchdown. It's either a touchdown or it's not a touchdown. It's either a goal or not a goal. So that's also another type of data that would be discrete. If you were to interview people on the number of family members you had in your household, right, those are numbers that we can count. Maybe you have 2 other people in your household. Maybe you have 1 other person in your household. Maybe you have 5 other people in your household. That would be a discrete data set. And then maybe the number of people falling asleep during this video. Did I wake you up? Sorry. So let's look at it on a graph point of view. So if I was an oceanographer or a marine biologist down in the ocean and I was observing fish, so for maybe every hour I would keep track of the number of fish that I observed. So for example, this might represent the number of fish and this might be the hour at which I observed the fish. So this would be my time. Okay, so maybe the first hour I observed 2 fish. Then maybe the second hour I observed 4 fish. Then maybe the third hour I only observed 5 fish. Okay, as you can see here, the number of fish that I'm observing is a whole number only. I can't observe 2.5 fish. It's either a fish or it's not a fish. So again, this is what we call a discrete domain. At this point, what I want you to do is fill in this side of the graphic organizer. So a set of input values that consists of only whole numbers in an interval. So that means it's the data that can be counted. A discrete domain is data that we can use that can be counted. So again, some real life examples might be number of people, amount of points scored in a sports game. You can say number of pets. Okay, so let's look at our continuous data. So a continuous domain or continuous data represents the set of input values that consists of all the numbers in an interval. So continuous data can be data that can be represented by any number on a number line. So for example, continuous data can be measured by time because time is continually changing. Your height. So if you were to keep track of your height from when you were born until now, it would be a continuous data because your height consists of all the numbers between every whole number. The weight of a car and the speed of a train. Typically, continuous data is measured in time, things like speed, weight, length, and height. So for example, if you were to take your submarine away from the port, because we all have submarines, and you were to graph your time versus your distance, so we can use our y-axis for time and our x-axis for distance you've traveled from the port. So maybe these can also be represented by hundreds, so 100, 200, 300, 400, so on and so forth. So maybe after 1 minute, you are about 300 feet away from the port. And after 2 minutes, you're about 600 feet away from the port. At 3 minutes, maybe you're only 700 feet, you had to slow down. But at some point, you are traveling at 400 feet, 500 feet, 600 feet. Unless you have some sort of magical submarine. I know Miss Frizzle might have one, but in reality, at some point, your submarine is continuously getting further and further away from the port. The submarine doesn't just jump from 0 to 300 feet just magically. So this is when you'd have a continuous domain. Okay, let's look at our graphic organizer. So the definition of continuous data is a set of input values that consists of all numbers in an interval. So fractions, decimals, etc. So it's data that can be measured. So things like time, your height or weight of something, the speed at which you travel. So those are some real-world examples that you might use for continuous data. And then at the top of your graphic organizer, I have the two main visual differences. So discrete data can only be specific numbers, and continuous data is represented by any number in the interval. Okay, if you have any questions, please feel free to write them down on the back of your graphic organizer, and we will talk about this tomorrow. All right, everyone, have a good rest of the night.